Hi, in this video, we're going to be looking at the 2025 KZN Trial Paper 2, focusing on question 9, geometry. And this geometry question pertains to similarity. So the question states that in the diagram, the circle with center O passes through F, S, H, and G. So we have a circle with center O. And if we know that O is the center, immediately I can see that OF, OG, OH are all radii. Goes on to tell us that DF and DS are tangents, and we know that tangents from a common point will be equal. Question goes on to tell us that SG is parallel. So if we're looking at parallel, what catches my eye immediately is looking for alternate angles, corresponding and alternate angles. SG is parallel to DF. We spoke about that. Then there's a diameter. FOH is your diameter, which intersects at SG and R. And the first question there is to prove that triangle DSF is similar to triangle OGH. So let's firstly highlight those two triangles, DSF and OGH. So here we have it. Some of the things that we spoke about, which is very important for us, let's just make a note for now. The two tangents from a common point are equal. We also see in the green triangle, those are radii. Okay, OG and OH are radii. So we have two isosceles triangles. So to prove them similar, we need to find two angles that are equal. And we will start by taking one of the triangles in the red triangle, and I'm going to start with F1. So let's call F1 to be X. And I'm going to write that down as soon as we try and get to the green triangle. So if F1 is equal to X, which angle will be equal to F1, which is X? And the first one that comes to my mind is S2. And these are alternate angles. Now, can I get to the green triangle from S2? Giving you some time to think. And if you've seen it, that angle H is equal to X, and that would be angles in the same segment. So let me just write that down as our starting point. We said, let angle F1 equal to X, and therefore we came up with S2, and we need a reason for S2, and we're going to say equal alternate angles, and the lines that are parallel was given to be, we can actually take it from the top if you're not sure, SG and DF. And from there, we went on to say that angle H is equal to X. And yeah, our reason was angles in the same segment. Now, it may be hard for you to see that, but if you draw an imaginary chord from there, then you'll be able to see the angles in the same segment. That angle H is equal to S2. So there's our angles in the same segment. And therefore, we can now conclude that angle F1 is actually equal to angle H. And that's a very important angle that we proved in the red triangle and the green triangle. So I'm going to clear my screen and go on to the second one. So let's say this was our number 1. Okay, so summary of that. Number one, we said F1 is equal to angle H. We're going to move on. And now we're going to go to S1. Now remember that earlier I said that two tangents from a common point are equal. Therefore, S1 will also be X. S1 is equal to F1. So I'm going to actually write that down. That S1 is equal to angle F1, which is equal to X. And the reason we're going to use here is tangents from a common point or from the same point. So I'm going to write that on here, the tangents from the same point. But we also, if we look into the green triangle, angle G in the green triangle, that means OGH, is also equal to X because of your radii being equal. In other words, we marked OH and OG. So I need to tell them first that, change the color, that OG is equal to OH, and my reason there is radii, and therefore we can conclude that angle OGH is equal to angle H, which is equal to X. And our reason there will be angles opposite equal sides. And therefore we can come up with our conclusion now that angle S1 is equal to the angle G, which will be your X. So therefore we can now conclude that S1 is equal to angle OGH, which is equal to X. So we have our second one. I'm going to clear my screen again. Okay, and that's number 2, S1 is equal to OGH, summarized. And now we go to the last one, which is your number 3. And the number 3 is quite obvious, some angles of a triangle. In other words, angle D will be equal to angle O1. And the reason there is sum of angles of a triangle. Sum angles of a triangle. So we have our 3 angles. The triangles are now equiangular. We can now therefore conclude that triangle DSF, which we can copy from the top, is similar to triangle OGH. And our case for similarity is angle, angle, angle. A AAA case. And there we've proved it. Okay, we're going to go to the second part of the question. And the second part of the question states, it is further given that OG is 7.5 and RH is 1.5 and find SG. So let's quickly put out those units into the diagram. OG is 7.5, RH is 1.5, and we need to find SG. Now, there's our entire line SG. So if we look into the diagram, what do we know? If we have a right angle triangle, we can use our ratios. So going into the triangle, we also know that OG is 7.5, that's a radii. So that means that OH is also 7.5. But RH is 1.5, which gives us 7.5, subtract 1.5, which means OR is 6. So we have two sides in a triangle. If we can find RG, that helps us a little. So we're kind of looking for the right angle triangle. So going back to the geometry theorems, we have a center, we have a tangent. So remember, the radius is perpendicular to a tangent. So we know that angle F sitting in there is 90 degrees. And then we have the lines that are parallel. So it means that angle R will also be 90 degrees. So we're going to write that down firstly. We're going to say, okay, angle DFO is equal to 90 degrees and your radius is perpendicular to a tangent. And then we got our angle R, which is ORG is also equal to 90. And here we have alternate angles. And the lines that are parallel was DF is parallel to SG. So it means we can use Pythagoras and find RG. So RG squared, okay, I'm looking at you not with me. I've highlighted the triangle. RG squared will be the radius squared subtract 6 squared. 7.5 squared subtract 6 squared. And my reason for that is Pythagoras. And we can use our calculator to find RG squared, which is 20.25. And then to find RG, we're going to square root that, the square root of 20.25 on your calculator. And that'll give me 4.5 units. And now, remember the question was to find SG. And we're going to use a theorem that a line drawn from a center of a circle, if it's perpendicular to the chord, it will bisect the chord. So we're going to write that down, that SG would be equal to 4.5 times 2, which gives you 9 units. And the reason is a line from the center is perpendicular to the chord, and therefore it bisects the chord. And that's how we get our 4.5 times 2 units. Thank you.